All right, we're continuing on with the 3.5 applications of inequalities notes. Starting off with example number 5. Here, Elvira is comparing prices between two different suppliers of lettuce. Val's Veggies charges $250 for delivery plus $1.50 per bag of lettuce. Sally's Salads charges $100 for delivery plus $4 per bag of lettuce. How many bags of lettuce must be purchased for Val's Veggies to be the cheaper option? All right, we'll start off this one by identifying what our variable x is going to represent. And we're looking for how many bags of lettuce there are. So that's what we're going to let x represent. X represents the number of bags of lettuce. Now we want to focus on how we're going to use an inequality here. So again, we're looking for Val's Veggies to be the cheaper option. Again, to be cheaper as compared to Sally's Salads. So if we're comparing Val's Veggies to Sally's Salads, and we want Val's Veggies to be the cheaper option, so what inequality symbol should we put in between these two? It should be the less than symbol. So here we have a kind of a plan how we're going to use an inequality for this word problem. We're comparing Val's Veggies, and we want that to be less than Sally's Salads. All right, let's try to write some expressions here for our inequality. Here we have Val's Veggies charging $250 for delivery plus $1.50 per bag of lettuce. So if x represents the number of bags of lettuce, and it's $1.50 per bag, we're going to have 1.50 times our variable x. Val's also charges $250 for delivery. So we have to add that to the Val's Veggies side of the inequality. Sally charges $100 for delivery plus $4 per bag of lettuce. So that side of the inequality, we have $4 times x plus the $100 for delivery. So here's our inequality that we set up here to solve for x, the number of bags of lettuce. All right, solving for x. Okay, we're going to undo operations. And then towards the bottom here, because we're dividing by a negative, we're going to flip that inequality. So here we end up with x is greater than 60. So that means for Val's Veggies to be the cheaper option, we would need to purchase more than 60 bags of lettuce. Okay, moving on, example number 6. A small boat has a maximum weight load of 750 pounds. Millie has to transport packages weighing 42.5 pounds each. We want to write an inequality that can be used to determine the maximum number of packages that Millie can safely place on the boat if she weighs 128 pounds. Then we're going to find the maximum number of packages that Millie can transport. Okay, so we're being asked to find the number of packages. So we're going to let x represent that. X represents the number of packages. So we're looking for a place where we can write an inequality. Here we have a small boat that can hold a maximum weight of 750 pounds. Okay, so again, we're going to be comparing that to what Millie has in terms of her packages and what she's carrying. So here we're comparing the weight of Millie and the packages versus the weight that's allowed on the boat. Okay, and so because there's a maximum weight load, that means we need the weight for Millie and the packages to be less than or equal to the weight that's allowed on the boat. Right? We can't be overweight or that boat is going to sink. All right, so Millie has to transport these packages, and each package weighs 42.5 pounds each. So we're going to do the 42.5 times X. All right, it's going for each package, again, it's 42.5 pounds. Then we're also going to add Millie's weight, 128 pounds. And we want that total weight to be less than or equal to the weight limit for the boat. All right, so there's our inequality that we can use to solve for X. All right, so we start undoing operations, isolating the variable, and here we get X is less than or equal to this long decimal. Okay, so again, here's a situation where, again, X represents the number of packages, and we cannot have part of a package, so we need to round this. So again, because we do not want to be overweight, we need to make sure that we round down for this one. So we're going to round that down to 14. All right, so the maximum number of packages that Millie can transport, right? She can transport no more than 14 packages. All right, so Orland Bowling Alley is charging $2.50 to rent bowling shoes and $4 per game. We want to write an inequality they can use to determine the maximum number of games that Ricky can bowl if he only has $20. All right, so we're going to let X represent the number of games. Okay, we're looking for how many games that Ricky can play with his $20. So again, we're looking to write an inequality here. So what are we comparing? We're comparing the money that Ricky has to spend at the bowling alley versus the money that is actually in his pocket. So the money that he's going to spend at the bowling alley has to be less than or equal to money that is in his pocket. Right? He cannot spend more than what he has in his pocket. So that has to be less than. All right, so it's $2.50 to rent the shoes. So he only needs one pair of shoes, so $2.50 plus $4 per game of bowling. So we're going to take that $4 and we're going to multiply by the number of games he bowls. So again, depending on how many games he bowls, that's how much he's going to spend, right? So $4 times the number of games he bowls. Again, we're going to compare that. We want that to be less than or equal to the $20 that's in his pocket. All right, so there's our inequality here that we can use to solve for X. Okay, the $2.50 for the shoes plus the $4 per game of bowl. So 4 times X. That has to be less than or equal to $20 in his pocket. All right, so again, undoing operations, solving for X, we get X is less than or equal to 4.375. Again, we got to round this one, all right, because we're looking for the number of games, and we cannot have decimals here. Again, because we are trying to stay within a limit, it's always best to round down. So we're going to round this down to 4. All right, so X is less than or equal to 4. So for Ricky in this bowling alley, he cannot bowl more than 4 games. 4 games is his absolute max. All right, going to number 8. It says for a business to realize a profit, its revenue must be greater than its cost. All right, so in other words, R is greater than C. A company that produces playing cards has a weekly cost equation of C equals. All right, so we got that equation for cost, and a weekly revenue equation for revenue, and then we have one for R. Where again, X represents the number of decks of playing cards produced and sold in a week. How many decks of cards must be produced and sold in a week for the company to make a profit? Well, again, in the problem, it tells you what needs to be true in order to make a profit. So we're looking at that inequality they gave you in the first or the second sentence. R is greater than C. It means the revenue must be greater than the cost. Again, revenue is the amount of money they're taking in. The cost is how much you're spending. Again, for profit, the revenue needs to be greater than cost. Now, since we have expressions for both the revenue and the cost, this one we don't need to make up any expressions because they gave it for you. All right, so we plug in the expression they gave you for revenue, and we do the one for the cost. So this one was pretty straightforward. All right, so now we can go ahead and solve for X. All right, so we get X is greater than 610. Okay, so for this company to make a profit, they would need to sell more than 610 decks of cards. All right, so Michaela accepted a sales position in Montreal. She can select between two salary plans. Plan 1 is a salary that's $300 per week plus 10% commission on sales. Plan 2, she's going to get paid $400 per week, but only make an additional 8% commission on the sales. It says, for what amount of weekly sales would Michaela earn more by Plan 1? And so since we're looking for the amount of weekly sales, X is going to represent that. All right, and because we are looking at a situation where Michaela is going to earn more by choosing Plan 1 versus Plan 2, that's how we're going to set up our inequality. We want Plan 1 to be greater than Plan 2. All right, so for Plan 1, she's getting $300 per week plus the 10% commission on sales. For Plan 1, I'm going to do the $300. That's what she's getting, plus the 10% commission on sales. So 10% as a decimal is 0.10, and we're going to multiply that by X. All right, so again, when it comes to percentages, right, we're always going to multiply those values to something. In this case, we're multiplying it to X. Plan 2 is given $400 per week plus that 8% commission on sales. So again, we're going to do the $400 plus 8% as a decimal is 0.08, and we're going to multiply that times X. So there's your expression representing Plan 2. All right, so you know what to do. We're going to solve for X. All right, so for this one, you should be getting X is greater than 5,000. All right, so for what amount of weekly sales would Michaela earn more by Plan 1? Well, Michaela would need to sell more than $5,000 worth of sales for that to be true. All right, that's it for today's lesson. Let's move on to the homework. We just continue on with the homework from yesterday on page 32, problems 5, 6, and 7.